There there are a lot of problems associated with drinking water, and then we'll see like what are the possible solutions that we are having available in the market. So this session will be about 45 minutes to 50 minutes. And in next 50 minutes, we will be learning about drinking water parameters, what are the different standards in India and international at the international level. And then there are different ways the water gets polluted, what are the sources and what are the impacts of those pollutions. Then we'll learn from some of the basics of the water purification technologies, and then we'll see what are the solutions available in the market. So I have been working in this area for last about 7 years, starting from 2007 to 2014. So in 7 years, we have explored so many things. So some of the work that we have done as a solution to the drinking water problem. So we'll discuss that also at the end of the presentation. So first and foremost question that we ask is like we have a lot of problems associated with the drinking water. So who is the main culprit for these issues? So I mean, it's not a good answer, but actually humans are the culprit for causing these problems. And in turn, humans are also getting affected by these problems. So these problems are actually created by us, and we are the victims of the problem that is created. How we have created this problem, we'll see in details. To start with, we have about 75% of the surface covered with water. Out of those water, 97.5% water is a sea water, that is salt water we call it, or brackish water, out of which only 2.5% is the fresh water. And that 2.5%, only 1% is fresh water that is available on the surface, and 20% is groundwater. So basically, these two sources of water that is available on the surface in the form of lake and rivers, and the one which is available in the ground. And these are the sources of water we consume as a human being. Groundwater we pump through our bore wells, hand pumps, and surface water we collect through pumping stations and then supply to the cities and towns. So you can see the total amount of water available for actual consumption is very, very small as in percentage. So when we say some water is a drinking water, so what is the parameter when we say this water is good for consumption? So generally, as a human perception, we have only two things that you can say three senses that we use to qualify some water as a drinking water. So first and foremost, we try to see like, okay, this water is looking clean, so it is a drinking water. And maybe we'll try to smell if there is no smell coming out of the water, and if there is no bitter taste. So with these three senses, we generally decide that this water is a good water or not a good water. However, this particular way of defining water is having a lot of problems, because there are contaminations which will not change the none of these three properties, but it will be really harmful for the consumption. So then over the time, people have categorized those contamination in terms of physical contaminations, chemical contaminations, toxic and pesticide, and microbial. So the physical ones are ones we actually generally try to sense through our senses, but the other contaminants, we are not able to sense them. There are special methodologies to do the measurement of those contaminants in the water, and there are certain limits for all of those contaminants, so that if those contaminants are within the limit, then it is safe for consumption. If it is not, then it is not safe for consumption. And that particular water we say as a potable water. So basically, for a water to be potable, all the parameters that is listed should be within the range. So what are those quality standards? They actually govern those parameters. So in India, we have Bureau of Indian Standards. The standard name is IS 10500, that is created in 2012. This is the standard that we follow in India. So for any um, supply water that we are having in cities, our corporation is bound to follow these standards. And for packaged drinking water, there is another standard they have to follow. And for purification devices, they have to follow certain standards. So for each kind of sources of water that we consume, there is a different standard and they are bound to follow those standards. Then in US, we have US Environmental Protection Agency, US EPA, they have a standard on drinking water. So if anyone is interested, they can go to these websites and see the details of the standard that they have. Apart from that, apart from those country level standards, we have WHO, which is in general like as a baseline for the entire world. So WHO has got its own standard for drinking water. So generally, US EPA is more stringent, WHO a little relaxed, and Indian is more relaxed. We don't have that much stringent criteria on drinking water standards. So essentially, how severe this problem is, how important this problem is. So essentially, it actually claims a lot of deaths every year, and many times it becomes headlines like the one I'm showing here on June 29, 2019. Polluted water kills 7 every day in 2018. So the last years they have done the survey, and then for India, they have published this data. You can imagine like it's not a small number. So WHO, they are actually keeping an eye on the entire globe, like how drinking water is affecting our life, what is the state of drinking water, and with respect to the population, what is the availability. So you can see like over half of the world population do not have safely managed sanitation services. So drinking water problem and sanitation services are actually connected to each other. So they are saying like around 2 billion people live in countries with high level of water stress. So along with the water pollution, there is another problem which is directly connected with this is basically the availability of the water. So if the water itself is not available, then what is the question of the quality of the water? So essentially these two problems, like whatever water we are having, it is getting contaminated continuously, and the second problem is like we do not have availability of the water. So generally the surface water what we get is because of rain, and the groundwater is essentially the one which is already presented in the soil. That was basically because of the rain that happened billions of years ago, and then slowly it was getting the soil, and it was getting collected in the aquifers in the ground, which is what we are actually sucking as groundwater. So you can say like petroleum, it is a fixed amount of reserve that we are having. So it's not infinite. So as you keep on sucking the water from the ground, the level goes down, and then amount of water that is having we are having is actually decreasing with time. So how we actually contribute to the contamination of the groundwater. So you can see like the light yellow, reddish yellow color is the soil, and then between the soil we have the aquifer, meaning the soil which actually is water rich, and they are generally connected to each other for a long distance. In sometime it may be connected to two aquifers may be connected to a distance which is in couple of kilometers also. So now you can imagine if we contaminate one of the aquifer at one place, this contamination is going to get spread below the ground. So we are having so many activities on our earth surface, like we are having this thermal power plant. They are going to release a lot of hot water. Then once we are having snowfall, then we put a lot of salt there. Then there are pumping wells that we actually pull water from the ground. And there are people actually, what they do, they have a bore in the ground and they basically inject those water in the ground. So they are actually saying that, okay, we have cleaned the surface and now we are not creating the contamination. However, the hazardous waste that has gone into the well, it is actually getting connected to other aquifers, and then this contamination is actually getting spreaded. So what is happening is, over the time, because of these activities that we are having, like in villages, we are having so in towns we are having sewers and then septic tanks, and then we are having landfills. So we create uh, big uh, uh, pits in ground, and then whatever city waste we are having, we just dump it there. And over the period of time when rain falls, it actually washes this waste, and then whatever wash is there, it slowly is going down in the soil and then going and connecting with the freshwater aquifers. So you can see, like, because of our activities that we are having on the surface, it is actually slowly percolating down the soil, and then it is getting mixed with the freshwater aquifer that we are having. And tomorrow, if we dug a new bore well, there is a good chance that the water that we are going to get out of the bore well will not be a fresh water, it will be a contaminated water. So this is really a dangerous thing, because what happens once this entire source of water is getting contaminated, then all the plants, all the vegetations, and those animals dependent on those vegetations, and then whatever product is produced out of those vegetations, actually they all contain the contaminant. So now you can see, like, whatever vegetables we are buying from the market, they all contain the traces of mineral, heavy metals, and toxic molecules. So, and this particular thing is continuously increasing, and then we are actually, entire cycle is actually getting contaminated with time. So that was contamination of the groundwater, and then we have the second source of water, which is the surface water. So now you can see, like, in the surface water, because of industries, cities, urban sprawl, construction site, farm. So they are continuously, because of their activities, they are dumping water into the surface water sources. These industries, they dump water which is contaminated. They are having lesser amount of oxygen dissolved into it. So as what happens near those dumping, all the the water life, they actually they because of lack of oxygen present in the water, they actually die. So it creates oxygen depleted zones, which is not good for this life. So essentially, in the aquifer, what happens, like, starting from the bacteria till well, there is a chain. There is a big chain. So if these kind of thing happens, the chain gets disrupted. So there are two problems that happens because of the disruption of the chain. Is like the lower organisms, they start growing without control, and upper organisms
छुआना
start
नहीं चाहती, टच
developing
भी करे नहीं ऐसे
without control.
करेगी।
Participants, please mute yourself.
So like we see, like, what are the different pollutants and what are the different sources. So you can connect, like, whatever problem that is there is somehow connected to our activities that we do on a daily basis. For example, like infectious agents like pathogens, you can say it is connected to human and animal waste. And human and animal waste is whatever waste we are creating. It is through our sewage pipe, it goes into the water bodies, and then eventually it comes back through our tap. So oxygen demanding waste, it is because of sewage, animal feedlots, food processing facilities, paper mills, they actually create the waste, which is oxygen demanding waste. Plant nutrients, basically sewage, animal waste, and inorganic fertilizers, organic chemicals, inorganic chemicals because of industry and household, mining site runoff, and so on and so forth. Sediments, again, land erosion because of farm and construction and mining sites. Heavy metals, unlined landfills, household chemicals, mining refuse, and industrial discharge. Actually, they put a lot of heavy chemicals to the groundwater and surface water. Thermal is because of electric power and industrial plants. So there, in thermal plant, we need water cooling towers to convert the vapor into water. So that generates a lot of hot water, and they actually just simply put those hot water into the surface water in whether it is a river or a lake. So you can see like our activities, they are actually creating problem into the different water sources. Then suppose, okay, we do all those things. So what is the consequence? So we see like in terms of bacteria, viruses, parasitic protozoa, and parasitic worms, they are coming back to the human being, and they are actually affecting our lives in terms of different diseases. Like you can see like diarrhea. Most of the time diarrhea, if it is in adults, they get cured because of medicine, but if it is happening in kids, they actually claim the life. So a lot of deaths are happening because of diarrhea in India even today. And and this is one of the major causes of child death in India. So a lot of health related issues are hitting India on a regular basis. India and other countries are on a regular basis because of the water contamination, which you know that created by most of them are created by us only. So looking at some of the chemical contamination, specifically arsenic and fluoride. So arsenic contamination, like in 2004, WHO said that over 80 million people affected in India and Bangladesh. You can see this is our Himalayan range, and from the Himalaya we have this river Ganga starting, and then it is going into Bangladesh, and then stopping at the Bay of Bengal. So you can see all this Gangetic Delta, and then in the sides of the river, both the sides of the river is having a lot of arsenic into water, and those people living near the Ganga and they're having borewells, they actually consume a lot of arsenic on a daily basis, and that is causing lot of diseases and even deaths. If you talk about the fluoride contamination, like a lot of states in India, like Rajasthan, Gujarat, UP, Andhra Pradesh, Tamil Nadu, they are having fluoride contamination in the groundwater. So these both arsenic and fluoride contaminations are actually groundwater problems. They are not the surface water problem. So over 60 million people across India drink water with high fluoride content. Fluoride is little lesser dangerous than arsenic, and it can be reversed. However, arsenic is really very, very dangerous, and it cannot be reversed. So we'll see some of the diseases that is actually being caused by the arsenic and fluoride poisoning. So I'm sorry, these images are really, very, very frightening. You can see like face and foot and palms. They are having like discolored, and then this texture is called hyperkeratosis, which is skin cancer. And the black foot disease, you can see um, the foot and fingers of the foot are, they are actually becoming black, and then skin cancer. So both on hand and the skin, they cause cancers. So arsenic is very well known in the history. What happens, like very, very small amount of arsenic in micrograms of quantity can claim life. It does not change the color, odor, and taste of the water. The person who is consuming arsenic contaminated water will never ever be understand that this particular water is contaminated with arsenic. Even if you are drinking some fresh water and then you get the arsenic water, by our senses, we will not be able to make difference. So because of these reasons, people have been using arsenic as a weapon. It's a secret weapon. If you want to kill some king or someone, then start giving them arsenic in water. Sometime the person within 3 to 6 months will die. So this has been used in history, and I mean there are a lot of information available on Wikipedia. If someone is interested, you can go through it, and you will find some very astonishing facts related to arsenic poisoning and the way it is used in history. It's not like arsenic is always bad. It is good also. It's a bracing tonic, and it is also being used in treatment of blood cancers. So some of very small quantity of arsenic is used as a medicine, and it is discovered that it can kill cancer cells, blood cells, which is cancerous. So people actually make medicines also out of it, but generally it is used as a with negative connotation in the history. Fluoride, like arsenic, it creates another problem. In case of fluoride, what happens? Fluoride has got a very strong affinity with calcium. So whenever there is a calcium, meaning teeth and bones, it goes there and through the blood, and then it binds there, and then over the time we see the discoloration of the teeth because there is a high concentration of calcium there. Near the joints of the bones, we see a lot of pains, and then it also decreases the strength of the bone. So the person is not able to take the weight, and because of the human weight, the bones gets bent. So you can see these images. So the right images that you can see, this is taken in Jhabua. So these pictures were actually taken by me when we visited these places. And this is boy. He was not able to even sit properly, not even able to walk. He was just lying on the. This lady. She actually born in some other village. She not born in Jhabua, and then she got married in Jhabua. After living in Jhabua for some time, this particular lady was so healthy, she became like this. So essentially, just to emphasize that fluoride poisoning is really crippling, and the person is not even able to live his normal life because of arsenic. So at this point, we are done with the problem of related to arsenic, fluoride, and other contaminations and sources of contamination and so on. Now we'll go some of the water purification technologies and try to understand like what are those technologies, how they work, and what is there available in the market. So basically those technologies, what they try to do. So you know that we have seen these parameters, physical, chemical, toxic, pesticide, and microbial parameters, which is actually there in the standards for different countries. Now, what is the goal for these technologies is to actually take those parameters and bring down within the limit of, so that the water which is available becomes a potable water. So that is the primary goal of those technologies. Now, not all technologies will take care of all the problems at the same time. Many times what happens, we have only one or two problems at a time in the water. So some of the technologies will be targeting only those problems, not all the problems. So that's why whenever we want to choose some solution, want to buy some purifier, then it is always advised to understand the problem first, so that we do not spend a lot of money in just buying some costly technology, which is just not needed. So first understand the problem and then go for the solution, and then that will work actually. So essentially, there are different technologies to address different parameters of the water that makes it a potable water. So first and foremost is the physical contamination. So we understand from the physiology point of view that physical contaminations are not actually bad. But from the perception, as a human perception, if something is not looking good, we would not like to eat it. So it is very important to remove any odor, any taste, any turbidity, and this which is there in the water. So generally what happens for odor removal, we use activated carbon. For pH regulation, we use acid and base. Sometimes we also use electrolysis to change the pH of the water. For taste improvement, again, we use activated carbon. For turbidity removal, we do physical filtration. Turbidity is generally suspended particle, which makes the water look dirty. So we do physical filtration, and many times we use sedimentation and filtration. So sedimentation, like those people who, for those people who have been living in villages, they would have used alum for the sedimentation. So if you put alum in the water, it will take all the dirty particles and then it will settle down, and you can just simply take the water from the top, and it is good looking. So this has been practiced in the past. For TDS, it is basically total dissolved solid. For that, we use water softener. And then in villages, like when we didn't have anything, we generally used to do evaporation. And then RO is the latest technology, which actually does the kind of evaporation thing. But it uses the latest technology. So we'll understand those technologies in detail. Okay, so now we have physical parameters for the removal of chemical contaminants. So we have the topmost technology that can remove all kind of chemical from the water is the RO. Evaporation condensation is second technology that is generally used to purify our seawater. So countries where we don't have fresh water available, and there are seas, but you know the seawater is a very salty, and it contains a lot of other chemicals. So to remove the chemical from the water, we use evaporation and condensation process. Absorption and flocculation sedimentation is another technology which is generally used to selectively remove chemicals from the water. So if you know that there is a 1, 2, 3 types of chemicals present in the water, then absorption becomes very important, because it simply removes that particular chemical, and other chemical it does not interfere with. For removal of microbial contaminations, we have ultrafiltration. So ultrafiltration is simply like physical filtration. You have some filtration membrane, and you pass the water through the membrane. It will simply remove the particles from the water, and then water will have free from the particle, and those particles can be bacteria also. Reverse osmosis, RO, is another technology. It will take care of the microbial contaminants. Ultraviolet UV, it disinfects water. Chlorine, again, oxidides the whatever organic material is there, including bacteria and viruses. Iodine, again, it is an oxidizing agent. It does the same thing. Nanosilver, again, it is an oxidizing agent. It does the same thing. However, chlorine is much faster than iodine and nanosilver. So before understanding the technology in detail, let us understand some of the fundamentals, so that we can appreciate the technology that is being used to purify the water. So first and foremost thing we would understand is the length scale. So what is the length scale? So suppose we are having one human, and 1 meter by 1 meter by 1 meter cube, you can say, in comparison to human being. It is almost the size of the human, little smaller than that. Then 1/10 of the meter is called 10 centimeter. You can say it is the baseball. You can hold 10 centimeter on your palm. But then 1/10 of a centimeter, 10 centimeter, or 1/100th of a meter is something which you can keep on our fingertip. But 1,000 of a meter is basically just a dot on our fingertip. So you can imagine a grain of salt is something is 1/1000th of a meter, which is we call as a millimeter, 1 millimeter. Now imagine this 1 millimeter is equal to 1 meter. Just imagine. Then 1/10 of a millimeter, 1/10 of a millimeter will become 100 microns. That is 100 micrometer. And 1/100th of a millimeter will become 10 microns. And 1,000 of a millimeter is a micron. That is 1 millionth of a meter is a micron. So if you take 1 meter and take a 1 million part of it, then one of them will become 1 micron. So generally you can see like 100 micron is our hair. So here we can see with the naked eye, but 1/10 of a micron, that is 10 micron, is our blood cell. So blood cell we are not able to see using our naked eye. So it will simply look like a red fluid, but it is actually not a fluid. There are particles, blood, which is red blood cell, which is present in the blood. Then again 1/10 of that is 1 micron, which is size of the bacteria. We can never see using our naked eye. So these sizes are seen under the microscope. So essentially now you can appreciate that we are talking like 1 micron and below range. So essentially any of these things we cannot see through our naked eye. So looking at the different contaminants that we are having at the length scale, that 1 millimeter is frog egg, okay, and then 0.1 nanometer is an atom, that is 1 angstrom. We are talking about viruses, which is 100 nanometer, bacteria, which is 1 micron, and then we are talking about animal cell and plant cell, which is about 50 microns. So you can see our interest is in this range, from starting from 1 nanometer to 1 nanometer to 1 micrometer, in this range. So if we are having protein, lipids, and C60, this kind of atoms, molecules present in the water, then we would like to get rid of them, because in this range we will be having some chemical which is harmful to us. Below that we'll have only water molecules, which is what we are interested in. So with respect to this length scale distribution with respect to the organisms, we'll see different technologies. So now talking about the membrane filtration, again we need to see like what is the size of those molecules that we want to get rid of using our technology. So you can see like 100 in micrometer range, it is 0.1 micrometer is less cell fragments, and 0.01 micrometer is viruses and polysaccharides, protein. 0.0001 0.001001 is like humic acids, protein, salts, and fatty acids. So we would like to get rid of these molecules from the water. So essentially we have to use our reverse osmosis. In this range we need to use nanofiltration. Before that we need to use ultrafiltration, and here where we want to get rid of only bacteria, we have microfiltration. Along with that, you can see that in order to use those technology, we require some pressure. For microfiltration, it is 0.1 bar. So 1 bar is equal to 10 to the power 5, and 0.1 million Pascal. So this is the amount of pressure. 1 bar is equal to 1 atmospheric pressure, roughly. So you can see like a fraction of 10% of atmospheric pressure is required for microfiltration. Equivalent to 1 bar is required for ultrafiltration, and nanofiltration and reverse osmosis require 10 times and 100 times of that. So essentially you can imagine like for these technologies to work, we need to have a pump to generate the pressure. That's why it will work, otherwise it will not work. Or else you need to keep the water overhead at some height so that it generates the pressure required. Then membrane technologies we have seen like microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. This is the distribution of how this particular technology is removing different parts. Like microfiltration will remove suspended particles, ultrafiltration will remove micromolecules, and this is the size that is given, and nanofiltration will remove dissociated acid divalent salt, and sugar. So basically, these are the big molecules. Then if you come to the smaller molecules, we need to have RO, that is reverse osmosis. Basically, it will remove our undissolved acids, monovalent salt. So very small molecule it can remove. Since the water is the smallest of all, the water will pass through and rest will not. So now you can understand that because of RO, we are getting the purest of the pure water. However, it also remove all the minerals from it, which is not harmful, which is good also. So RO will remove everything and it will also remove good elements from the water. So what is reverse osmosis? How it actually works? So osmosis is the process when we keep something very high concentration and in contact with low concentration. Okay, and that separation is through a semi-permeable membrane. That semi-permeable membrane means it can allow very small molecules, but it will not allow big molecules. For example, if you are having a grape and if you put in salt water or sugar water, then eventually it will lose water, it will shrink. So this particular process is actually, you can say, naturally preferred. As a result, you can see whenever this osmosis happens, it creates an osmotic pressure. The level of low concentration liquid is lower than the level of high concentration liquid. Now, in the reverse osmosis, what we want is high concentration water should pass through the semi-permeable membrane and it will give me low concentration water. So in order to do that, we need to have an extra pressure over here so that if this happens, otherwise naturally this will not happen. So that's why you can imagine like for the reverse osmosis to happen, we need to have a high concentration water and a semi-permeable membrane along with a pressure which is applied on top of the high concentration water. And this is what is actually used in our RO devices. So what happens in RO devices is basically we have water along with the different, you can say, different molecules, ions, and bacteria, viruses, everything is there. It passes through semi-permeable membrane with pressure, and then what we get is purified water. So along with that, we have two more technologies that is used because we have used carbon, activated carbon for the removal of odor, taste, and color from the water. So what happens, what it does actually. So there are two processes that happen. One is absorption and one is adsorption. So what is absorption? Absorption is essentially filling the gap of one material with another material. For example, if you have a foam and that foam, if you dip in water, then water will be filled within the cavities of the foam. So this is called absorption. Okay. So what is absorption is? Absorption is essentially binding the molecule of one component to the other component on the surface. So essentially at the surface, there will be some active sites that will actually attract those molecules and bind itself. So if there is no chemical bonding within those surfaces, only attraction force is there. This is called physisorption, and if there is a chemical bond form, then it is called chemisorption. So this activated carbon is actually provides those active sites. It is a porous in nature, so that gases, water molecule, gas molecule, they can go inside the carbon, and they on the active site they bound themselves. So because of that, what happens whenever we put some water which is having color or something, so that color is because of some molecule. Those molecules will go and bind to the carbon molecules, carbon particles at the surface, and whatever is coming out is only H2O, that is water. So because of that, this activated carbon is able to remove color, odor, and taste from the water. And this is something which is in general used for all the tabletop devices. Activated carbon is integral part of the purification devices. Now we are at the third part of our presentation where we'll talk about the water purification solutions. And specifically we'll be talking about household water purifiers because there are different industry scale purifiers. I understand because we are mostly We are not from the industry. So as an individual, we are interested in household water purifier. So if you go to the market, you will see a lot of such devices. They will be having written on top like UFRO, UFRO, UV. Okay, so this kind of thing is written on top, and then they claim that this gives you best water, this that. So we have understood like what actually happens when we say UF. UF is ultra filtration, meaning it is a membrane with pore size 1 micron. It can remove bacteria. RO we understood like this is a reverse osmosis. It can remove bacteria, viruses, and also big molecules, small molecules from the water, and also remove bad and good all the molecules from the water, minerals. Then ultraviolet is something which disinfects the water. So this also produces a lot of wastage of the water, because in the RO process, not entire water is going to pass through the membrane. Some of the water is always rejected, which contains high concentration of the chemicals. So this particular technology actually produces wastewater all the time. Also, we understood that it runs at a very high pressure, and which is generated by pumps. So it requires electricity to purify the water. Then we have chemical plus membrane purifiers. They call microbial water purifier. So they are not talking about the removal of any chemical from the water. They are microbial, meaning they are actually try to disinfect the water by putting some oxidizing agent like chlorine, iodine, and silver into the water, so that the bacteria and viruses, even if it is there in the water, it will not be able to multiply itself, and that we call as a disinfected water. Or else they will have the membrane, that is ultrafiltration membrane. You can say that is 1 micrometer or below that size. So it will be able to filter the bacteria from the water, so making the water safe for the consumption. So in this range, like you can see, like Purity is one of the very well known in Indian market. Tata Swatch is one product that is by Tata Chemicals, and this is the one product that we have worked on this for about 3 years together. So a lot of technology that has gone into it. We have worked on it. Then we have a purifier by Kent, by AquaGuard, and so on and so forth. So after this, we'll be talking about some of the technologies that we have developed with respect to Tata Swatch. So Tata Swatch is household water purifier. It is affordable nanotech water purifier. Nanotech means we are using nano silver here. We are not using any activated carbon. Instead of using activated carbon, we are using rice husk ash. That is basically the shell of the rice. After burning, we get a lot of carbon inside it, also with a lot of silica in. So within the silica, we generate nano silver, which is bound within the silica structure. And when water passes through it, it gets disinfected, and we get pure water. Since we are using very small amount of silver and then rice husk, which is basically kind of a waste, agri waste, so we could reduce the cost of this purifier to a very small value. This particular water purifier can purify about 3,000 liters of water with single cartridge, and then once it is exhausted, you can replace the cartridge and reuse the purifier. So this is the cartridge. It looks like this. In this, there is a red color, which is a life indicator. So if the red color is at the bottom, generally it will stop the flow of water, and then you understand that okay, now life is over. We need to go and buy another cartridge and replace it. So it is designed in such a way that anyone can replace it, even ladies at home can replace it. So it is good. I mean, maintenance and everything is reduced, so the cost is also reduced. Along with that, we have worked on the arsenic and fluoride filters. So these are the purifiers that is already there in the market. So especially with respect to arsenic and fluoride, we have seen that problem is related to groundwater, and it is there in villages. In towns and cities, we have surface of water, and then we have purified water available in the tap that we are having. But in villages, they are dependent on groundwater. So if there is some contamination in groundwater, they are bound to consume that. So essentially, in villages, generally we have poor people living, and the rich people will go to the cities. So then it turns out to be a problem of poor. So if you devise some of the solution like RO and all, we don't have power availability. We don't have these people don't have money. So basically, those solutions are not viable solution for them. So then NGOs and other people, they work and try to come up with solution which they can afford. So you can see like sono filter. This is generally used in Bangladesh and those areas. They are handmade and basically just to use some local material to purify the water so that they can manage themselves and they don't have to invest a lot of money. In line to that, we have also created some of the purifier, like this is the cartridge for arsenic purifier, so that we also try to use some local materials along with the high-end technologies that is in the form of a cartridge, so that they can afford also and they can get the benefit of the high-end technologies. So these are the purifier we have put in some of the villages like Yadgir district in Karnataka. After these coal mines, they actually contaminate a lot of groundwater. So before there were no arsenic in Yadgir district, but now because of coal mines, this arsenic in water is now increasing with time. For arsenic, for fluoride removal, the same thing we have done. We have created a cartridge using rice husk and then alumina. We have coated on the surface, and this purifier we have created and tested. So this particular fluoride removal purifier we have tested in Jhabua district because the Jhabua is basically border area of MP and Gujarat. And then almost entire Jhabua district is having a fluoride contamination in the water. So I visited with my team and tested some of the water that was available there. And some of the government installed facilities was also there. Some of them were working, some of them were not working, and so on. So along with that, we have also done research on some of the portable water purifiers. Like suppose you are going out and you are not sure of the purity of the water. So essentially you take something like a pen and then dip the pen in the water, and then after 5 minutes you can consume the water. It's basically a chlorine doser. It will disinfect the water if there is a bacterial contamination. Other contamination like chemical and other thing, it cannot help. In the same lines, like where we have this bacterial contamination, generally when villagers, they go to some pond, lake and river and try to take that water for consumption, generally it has a lot of bacterial contamination. So people say like if you just chlorinate the water, it's good for them. So we have created this stick. We take a bucket of water and stir the water with the stick, and the water is safe for consumption. So this particular stick we have distributed in Chhattisgarh, Batsar district through our one NGO. Then we have also created this arsenic cartridge, which can be packaged like a Tata Swatch container and then be sold to those people. Then finally, what is the actual need? So if we see like about 15,000 and that range, we have these RO technologies available. So basically rich people can afford it. For the middle class, like rupees 1,000 plus, we have a range of purifier, which is kind of a tabletop solution, does not require any electricity or anything. But it's just, generally it is good for people who are having tap water, they want to double shower themselves, and it works like Tata Swatch Purity and all, it falls into the same category. So middle class people, they generally can afford this and manage that. However, for those people who are living in villages, they are fetching water from well, river, pond. They don't have the availability of the water. They don't have money. They don't have any all these things. What should they do? So then we came up with some technologies which we can actually using some of the ready materials, and then through NGOs we can teach them, and then they can actually deploy them in those areas. So this is one of the chlorinator. We call it a funnel water purifier. So it is simply a chlorinator. So we created this cavity and put the chlorine tablet inside it, and then plug this this into the funnel, which is already there in the market. Just while pouring the water, what happens? It maintains a very specific concentration of the chlorine to the water, and that particular amount of chlorine is sufficient for the disinfection of the water. So this was very good. I mean, some of the NGOs, they like this idea and then adopted it. So I have a small video. I don't know it is going to work or not. Just let me if it is working. Okay. So the idea was like to come up with some technology which can really ensure safe water with a very less amount of money. So this was one technology we developed. Then there was some problem like, okay, microbial is okay, but can we do something with the chemical problems also? So then we came up with this idea like, instead of having so sophisticated cartridges, we can buy containers from the market and then some raw material from the market which is available, and then package them and put in a bucket. It will work as if it is any other product. So like we have a branded medicine, it is a generic medicine. So you can use all the local material and then produce the same thing with the same quality. So that's how we have created this. We call it 3-in-1 water purifier. That is called, in short, we call it Stino. And this particular thing we have given demo and then had a session with the NGOs and made them learn, and then they are using with some modification in the field. So in Jhabua and other districts. So with this, I stop my presentation. So we can take questions now. Hello.
Assalamu alaikum.
What is now?
Dilshad, what would be the cost per liter of filtration in the large scale? If
What
you
is the
think of
cost
putting
per?
up in a...
Sorry, can you repeat, Shalom bhai?
No, what will be the cost per liter or per 1,000 liters for installation and the maintenance if we think of installing in the school or something like that in a village areas?
Also for a school and for a community level, we need to go for industrial scale purifiers. So their pricing is completely different. Generally, household purifiers are costlier than the community based.
So what all we have seen here is purely for the household purpose only.
Correct. It's purely for the household purpose.
Assalamu alaikum, Dilshad Ahmad bhai.
Ji wal Islam.
Very wonderful work based on field research and particularly good solutions for the rural and tribal areas. We also face this kind of problem when we go for field work in anthropology and archaeology research.
Okay.
So very good. Just I wanted to know recently, apart from these, what you have mentioned, RO technology, etc. There is another water purifier which is making a lot of sound, that is Kanjan water, which cost nearly 2,50,000, and where they are claiming what is known as, it is like Zamzam water or very pure water, which will solve all problems, etc. So what is that kind of technology?
Which water I didn't get?
Kanjan water, Kangen, Kanjan Japan technology water.
Kanjan water.
Yeah.
Somehow I have not come across, but this Japan technologies, what I understand is basically a lot of noises. They are actually doing the electrolysis of the water, and they are trying to create alkaline water. And then alkaline water they are selling like it will cure a lot of diseases and so on.
Yeah.
Is it that?
Yes. It's
Correct.
same type of technology. Yeah.
Okay. Actually, I was expecting this question from someone, so I kept one backup slide for that. so, so alkaline water. So what is happening is alkaline water means the pH is above 7. So generally about 6.5 to 7.5 is the potability range for the pH. So if the pH is about 8.5 or so, it is called as alkaline water. Strictly, if it is above 7, it is alkaline water. But these people, they are saying 8.5 to 9.3, that range, they say as the alkaline water. And then they are talking about a lot of diseases can be cured using this water. Mainly in Japan, they are having devices and they are selling in their country and other countries also. In India, a lot of people are actually marketing that particular device. Now coming to the actual fact. So from the research that people have done, and with the very famous website that actually publishes latest research on these topics, what I could gather is there are two different group of people. One group of people is actually supporting alkaline water, and they are claiming that it will cure your abdomen related problems and obesity problems, or your it can also cure cancer and so on. So basically anything you can think of as a disease, this can cure. That's how they are claiming. Now the other party, basically those people who are going by the research, proper clinical trials of this particular technology. So there are two things that is seen. One, this water is actually having higher pH. So if someone is having some abdomen related problem because of acidity and so on, it helps. It helps, and the people have found that they feel better, and the stool motion is also smooth. Second thing they are finding is if someone is basically doing workouts, and after that if they take this particular water, then change in the viscosity of the blood is about double. So generally if you take the same normal water, it will be 3 point something, but if it is alkaline water, it becomes 6 point something. So these are the two findings people have found, but it is not like generally accepted. Alkaline water, the effect, health effect and so on is not, you can say, strongly backed by the this community. Okay, so there are like you can say those groups, they are actually claiming different thing, but it is not verified by the experts and those community, and it is not accepted by our medical community. I mean, the doctor in general, they do not recommend drinking of alkaline water in case you are having some disease. Okay, so that's how this particular state is. I don't know exactly. Maybe tomorrow some people do some very serious study and then come up that as a alkaline water as a solution to some of the problem, or it may also turn out to be other way around.
Okay.
Hope that answers your question.
Yeah. Thank you.
Yeah.
Shukriya. Another, if there is time, just I wanted to ask another one.
Yes.
Everywhere in Hyderabad, or even I am from Kadapa,
Okay.
everywhere the people are selling water for
Correct.
20 rupees, 30 rupees.
Correct.
So we just simply buy, and we are drinking. We don't know how they are doing, etc. And we don't know the industrial factory or where they are doing that.
Correct.
Just they are supplying in our flats and we are drinking. So how can we check now and then at least the purity of that water?
So, frankly speaking, checking the purity of water is not an easy task. It can be done only in laboratories. However, what we can do is we can buy a TDS meter. Meter is like your thermometer. It's very small, like a pen, and you can buy it and just measure the TDS. So, if what those people are doing is generally they are having industrial scale RO plants and they pass the water through RO. They maintain the TDS value to about 50, 60 and then sell it to us. That's it they are doing. So if we want to do anything at all, we can actually do a TDS testing and see like what is the value of the TC. So generally what happens if the TDS value is very low, then all the chemicals are removed, including good chemicals. So then we can say that, okay, we can consume this. So that's how we can do our own. Otherwise, you have to go to laboratory, send the sample to them, ask them to test different parameters, and they will give the report.
Okay, what is the healthy TDS range accepted?
So from the medical point of view, TDS is not a problem. It is a basically is a physical parameter. And because of the taste, people do not like high TDS values. So we can go up to 150 and 200. Beyond that, it's not actually drinkable because of the bitter taste. But very low value of TDS, generally our corporation, they maintain 50 PDS, but below 50 is not recommended. It has adverse effects. So I would generally, if someone asks me to, I would say like be around 100. Don't go to 50, don't go to 200. So that if you go out and you have some other water to consume because of some reason, then you are safe, like you don't have any issue.
Shukriya.
Yes, Assalamu alaikum, Dilshad bhai.
Well, slowly.
Jazakallah khair for that very insightful presentation. A lot of new things we got to learn. Just a few questions, like for our homes, for example,
Yes.
what we are doing. So so one of our new residences that we are planning to move in, we just got one of the test labs to come and do a test for us, for the just to understand what the parameters are. So they gave a test report for about 16 or I think almost 20 different parameters, that we did separately for metro water, that coming from the city, as well as for the bore water. I'm not sure how exactly to interpret that. Now we have a lot of these other companies who are trying to sell their solutions. It's mainly just residents, but with all these different, like one of the slides that you showed with all those whole different range of solutions that are there. Unfortunately, I'm still not in a position to understand all the parameters very well. I think your presentation has helped me to some level. But do you recommend any any people in our community who would be like yourself, who would understand these reports better, that I can share it with them, get their feedback, understand how pure our level of water is, and even for our other brothers also over here who can share their reports and get some advice on it? Would you be available to do that, Dilshad bhai, or is there someone else that you would recommend that we can even approach just to get suggestions on what we should do once we have these reports with us?
Actually, the first help you can take from the laboratory itself, that would be good. Second, if you want to verify yourself, you can go to the website and download our Indian water BIS standard. And from the BIS standard, you can just compare your report and see like whether the values are in range or not. So if they are not in range, so essentially we are having majorly two kind of contamination. One chemical contamination and the other one is microbial. If your chemical contaminations are in range, then you can go for all tabletop solution like Puri, Tata Soch, and so on and so forth. If it is chemical contaminations, then you have only one solution, that is RO. So for RO, I can recommend is whenever we go for RO, when your TDS is very high, and if you are having a laboratory test which shows like there are heavy metals and so on and so forth present in water, then going for RO is must. There is no other solution. But when we install the RO, ensure that you have a ultrafiltration membrane installed first, and then after that you have a RO membrane. So what happens if you put ultrafiltration membrane, it will take care of the big particles, and then your RO life of the RO will go up. Otherwise, what will happen, every 6 months, 8 months, your RO cartridge will choke up, and then you have to call the service engineer, spend a lot of money. Second thing, what I would advise is do not keep the TDS value very low. Even 50 is very less. Actually, keep the TDS value about 100 or so, and try to maintain that. So putting ultrafiltration before that, and then maintaining the TDS to little higher value, not to a lower value. Actually, this is something is advised.
Noted, brother. For example, our TDS value here for our bore water is 468, and for
It's
our
very
metro
high.
water is 405.
It's high.
So okay, so
150 or so is something we can manage without any filtration, but beyond that, otherwise you'll have kidney stone and other problems starting.
okay. Now, how do we measure this TDS level? Like what you're saying, on ongoing basis, like all these solutions, do they actually have a TDS? Do they show the display of the TDS, on the device itself?
So it's not any standard like everyone has to keep that. Maybe you can check with the device and vendor. However, if you are interested, you can buy a TDS meter. It's like a pen.
Okay.
Yeah.
Yeah. For those of us who don't have much knowledge, do you suggest any good solutions for this, like for the home use of these things, like one of like Aqua or Eureka Forbes or Tata? Any particular models that you recommend?
Brother, actually the thing is the membrane manufacturers are the same. These are just a brand, and they have designed their devices like to look different, and they claim and they have ads. However, the fact is the membrane manufacturer is the same.
Okay.
Meaning the underlying technology is exactly the same. So
Okay.
then what we have to bother about is basically we have to put this ultrafiltration membrane first, and then keep the TDS value at little higher value. Then we have to talk to in terms of what will be the maintenance AMC charges. So since the technology is basically same, you have to think in terms of the charges. So whoever is giving you better service, go for it.
Noted, brother. Jazakallah khair.
So is there any question we can take, or else we conclude the session?
Although, is it possible that you could share your contact as well, that we can be in touch with you when, as and when the need arises, and we can get your advice in the future?
Yeah, I can share my contact. But I would request to text me instead of sending me directly calling me, because I may not be in a position to pick the call all the time.
Of course, inshallah, we'll do that.
Dilshad bhai, assalamu alaikum. This is Sarfraz from my side. I have one question. Thank you for this wonderful presentation and your research. So I had one question. Means once the water passes through an RO, we lose the healthy minerals as well, right?
Yes.
So can as there is some copper technology, can we regain it after passing through RO? Can we regain that mineral? So it will be helpful for our body and maybe our children's as well.
So basically, brother, the problem is like this. We are removing all the minerals because we cannot differentiate between the good and bad. The RO technology cannot differentiate between the good and bad. Essentially, there is no way to differentiate. Sorry? Hello? Yeah. So there is no way to differentiate between a good mineral and bad mineral. So RO does not understand that. So you have seen like RO technology is simply working on the size. So if the molecule is of big size, it will get removed. If it is of a small size, it will remain there.
क्या बोला? अच्छी। एक
Got
आंसर
it.
दे। ये हमको लग रहा है जास्मीन है शायद, क्या है का चीज? ये जो
Someone is on.
Yeah, I'm muted. Okay.
on-
So there is no way to do that. So however, if you see like earlier, we used to have some of the bottled water.
सब पानी
We
ना
used
मिलने
to
की वजह
sell
से सब
bottled
स्कूल खत्म हो
water.
गया। पानी जिम्मेदार है, पानी तो है। और ये सब घास वास आया था कि इस पे धस जाए, तार पे जो है
Hello.
ये कुछ दिन
Sorry. So there earlier, I mean, you would have seen like the people used to send this packaged drinking water. They used to call as a mineral water. You know, they used to say that we have a added mineral into this water. It is good for health. So
Yes,
the
yes.
thing was like it was added mineral because of the simple reason they were doing the purification using RO, and in that process they were removing all the minerals. And they realized over the time that if someone is consuming this water continuously, it will have adverse effect because we are losing a lot of good minerals. So though to manage that, they used to add some of the minerals. So essentially, what is that mineral? If you remember, or you would have seen that bottle. So as a mandate, they have to write what is the mineral. So it is mainly magnesium carbonate, calcium carbonate, and some of the other minerals. So magnesium carbonate is essentially a substance which is a laxating agent. Laxating agent means it will help in passing the stool. So those people who used to have this water, they used to feel very good actually because of this thing. But it has got other problems. So now you see like no one is selling water as a mineral water. No, everyone is selling water as a packaged drinking water. Because
Correct.
that mineral thing is now gone from the marketing. So that's how it is. So we cannot do that. So because of that, what we say is do not decrease the TDS value so much. Otherwise, you will lose everything. So keep it
Okay.
a little higher.
Yeah, and what about the copper thing? I think now some new technologies are coming which is adding copper. I think I've seen one of the ad for Eureka or something.
So copper and silver, it is, I mean, traditionally in Indian subcontinent, we used to have it in our regular utensils. Especially if you see like kids, when we used to have our kids, then in order to feed milk, we used to have a silver spoon. Okay. So the reason why you used to have silver spoon or for small kids, we used to have silver utensils was the simple reason. Silver and copper, they are bacteriostatic. In the sense, if you keep something within silver and copper, it will not let the bacteria grow within it. And milk and other thing is really basically a lot of food is there for bacteria, so they will like to have milk and they would like to grow themselves. That's why if you just keep the milk like this outside, then it will get spoiled. So by the copper and silver, it is very good bacteriostatic in nature. That's how traditionally we used to keep our water in copper vessels, and food also in copper vessels. It helps in keeping it fresh for longer time. So these people are trying to utilize that particular, you can say, property of copper. However, there is something negative associated with copper. If it forms oxide, so copper oxide is not good for health. So used to have that problem earlier also. So maybe they would have done something with that. In case of Tata Soch, if you remember, I've discussed, we are using nano silver. Again, same thing, because then the silver has got that property. We are trying to use the same property, which is oxidizing property to purify water, and which is generally known, I mean, traditionally. Hope that answers.
Yeah. Shukriya, Dilshad bhai. I got my answer.
Okay, do we have any final question
Yeah,
before we close the session?
Yes, just final from Dilshad Ahmad bhai. Can I ask now?
Yes, yes, yes. Sir. You can ask.
Just because you are from a research community and you have done a lot of research in the laboratory and rural areas. Usually in rural areas from our childhood, we have seen that we use the clay pots.
Clay pots, yes.
Clay pots.
Yes.
So have done any research and how it helps for all these kind of new technological innovations and how you
Okay.
compare it with clay pots available, particularly in the summer we get in the city also.
Okay. So clay pot is not for purification of water. It is for keeping the water at low temperature. It helps in decreasing the temperature of the water. That's why in summer we go use clay pots to store water. It makes them water cool. And that happens because of the porous nature of the clay pot. So water actually seeps through the pores and then the entire pot gets wet, and the outer surface of the water, because of high temperature outside, it gets evaporated. And in the process, when we have evaporation, what happens? The temperature of the water comes down naturally, and that makes the water cool. Now the same technology people are using. They put sawdust into the water and then make a candle out of it. So you would have seen candle filters. So the technology is exactly the same. What we are having in membrane, they are doing the same thing in candle. So putting sawdust in the clay and then baking it, it will actually create a pores inside the clay, and then water is passed through that. So it is like a microfiltration. It will remove all suspended particles and bacteria from the water. However, for small particles, chemical and viruses, it cannot help. So it is very slow filtration process, but it is very good because we have sawdust available in villages, we have clay available, we can bake it and then make a candle out of it and then put the candle in any container and you have the filter available with you. So it is very good technology. However, the pots per se is not a purification device. It's just a cooling device or a storage device.
Thank you. Thank you, Dilshad.
Okay, so
Okay,
looks like,
Dilshad.
yeah.
Okay, thanks a lot for this very interesting and informative presentation. And thanks to all the audience.
Yeah, just one
Making it
question
live.
if I can ask. Just one. Assalamu alaikum. Can you hear me, Dilshad bhai?
Yes, yes. Firoz.
Yeah. Just continuing to this question, once our brother has asked just now. So my question is like there is a one trend like a copper jar. There is among the market. If we use water, keep water in that copper jar and drink that water, so it is good for health. So just can you elaborate on this topic? How much it is helpful since we have done research on this subject?
Yeah, actually, this is very well known in our Indian tradition. I said, copper and silver is a bacteriostatic in nature. Meaning, if we keep the water outside, there is a good chance the bacteria will come from air or somewhere and it will grow inside. And if we consume this water, it will create issues. However, if the same water is kept in copper vessel, whether copper jar or anything, copper is able to make water bacteriostatic, in the sense bacteria will not be able to grow because of copper. So if you use that water, obviously we are safe from the bacteria and then we are healthy.
Okay. Thank you.
Yeah, that's how people, I mean, this is very traditional thing, copper thing. It's very, very traditional, very old thing. We used to have in olden days. Then we have this silver and steel came and we are started using this. Obviously, copper is costly. Silver and steel is cheaper. So we moved from copper to this thing, but copper was well known.
Dilshad bhai, Abdul Sami speaking.
Yes.
Dilshad bhai, apart from oligodynamic action, there is no added advantage of it. Am I right?
In which case?
In case of copper usage,
Yes.
there is a concept called oligodynamic action, which inhibits bacterial growth.
Correct.
The only advantage, and there is no other advantage apart from that, I think. I mean,
Yes. Yes. See, in case of water, there are only two things. One, it should be safe. That is potable water. It should not have any pathogenic bacteria and viruses into it. And second, we need to have minerals in water. That's how this our Himalaya water that is sold by Tata, because they collect the water from Himalayan ranges and then they claim that it contains a lot of good minerals. So mineral and free from bacteria and viruses, other thing, harmful chemical is the only requirement from the water.
Jazakallah khair.
Okay, Sept,
Okay, shall we close now? Yeah, thanks. Jazakumullah khair. Dilshad bhai, very nice session, mashallah.
Shukriya.
Okay, assalamu alaikum everyone.
Yeah, thank you so much. All of you. Bye.